Hello, this is Kate from Laminar, chemical reactor manufacturer for graphene and graphene oxide. Today, I'm going to introduce the continuous process technology using Taylor flow for graphene and graphene oxide. My presentation will be covering what the Taylor reactor is, advantages that the Taylor reactor brings, application with the Taylor reactor, products, and the brief company introduction. For the graphene production, there are two main categories, top-down and bottom-up manufacturing techniques. Under the top-down manufacturing techniques, there are dry exfoliation, like Scotch tape, liquid phase exfoliation, chemical reduction of graphene oxide based on Humus method, and electrochemical exfoliation. Bottom-up manufacturing techniques, there are direct chemical synthesis, epitaxial growth, plasma-based methods, and CVD. These graphene production processes keep changing for the process improvement. The most mentioned challenges are scalability, number of layers, structure damage, size, quality, operation condition, and cost. However, the Taylor reactor based on the liquid phase exfoliation can meet all these requirements. So first, you don't need to worry about the scalability. Since we have a wide range of working volume reactors, you can produce just a liter of graphene for your R&D, but also large quantities for the mass production. Of course, the production rate varies per meters, but about 2062 tons can be produced yearly. Several publications reported the Taylor reactor can produce the single and few layer graphene without any defects. Also, it is easy to control the size by the agitation speed and exfoliate the uniform graphenes. Our Taylor reactor runs at the room temperature, not at the high temperature or under the vacuum condition. Lastly, the production cost can be significantly saved, as the Taylor reactor not only shortens the reaction time but also saves the water consumption for rinse. What makes this possible? The answer is Taylor flow. For flow, there are laminar and turbulence flow. As you can see the picture of candle, the laminar is straightforward flow without being disturbed. Turbulence is irregular flow like waves, rivers, and clouds. Laminar flow is not used in the reactor because it has no mixing power. So turbulence is used for conventional reactors such as batch and PFR. However, because of the use of irregular flows, the materials are randomly mixed and reacted, resulting in a bad results. However, our Taylor reactor is utilizing the Taylor flow, which is the transit area between laminar and turbulence. As you can see the picture in the middle, the Taylor flow is mixing particles homogeneously within the Taylor vertices and brings high reproducibility. So our Taylor reactor is easy to scale up thanks to toroidal vertices. The flow created when the fluid flows in the gap between two different cylinders, but with the same center, and the inner cylinder rotates at the constant speed, is called Taylor flow. The fluid close to the inner cylinder tends to move toward the stationary outer cylinder due to the centrifugal and Coriolis forces created when the inner cylinder rotates. The fluid gets unstable, and then a pair of rings rotating in the opposite direction each other is created along the